You're working on a spreadsheet and it just gets messy, where changing one tiny thing somehow breaks something else and pretty soon you're not even sure where the right information is anymore? Well, it turns out there's a whole science to preventing that kind of chaos. Today we're going to pull back the curtain on the invisible logic that keeps our digital world organized, reliable, and, sane. Okay, so here's our game plan. We're going to start with a super common mistake. Then we'll uncover the hidden problems it creates. After that, we'll look at the cure. And finally, we'll get into the powerful concepts that literally keep our digital world from falling apart. First up, let's talk about the one big table approach. I mean, on the surface, it seems like the easiest way to do things, right? Just dump everything in one place. But this simple choice is actually a trap, just waiting to spring. So imagine we've got this table to keep track of our employees and their departments. Pretty standard stuff: ID, name, department, and where that department is located. But do you see it? For Nick and Lily, we've had to type in New York twice. And that tiny bit of repetition, that's our first red flag that something's not quite right here.
All right, let's put this design to the test. Let's say the HR department decides to pack up and move to a new building. What happens in our table now?
Well, now we have to go on a scavenger hunt. We've got to find every single employee in HR and manually change the location. If you miss just one, bam, your data is instantly corrupted. Now some records say HR is in one place and others say it's somewhere else. This headache has a name. It's called an update anomaly, and it's a direct result of that repeated data. Okay, so let's try something else. The company is spinning up a new innovation department. It's official, but they haven't hired anyone yet. How do we get that new department into our system? And the answer is, you can't. With this setup, it's actually impossible. The whole table is built around employees. If you don't have an employee ID to put in the first column, you can't add the department's info at all. This really frustrating limitation is what we call an insertion anomaly. And now, we get to the most dangerous problem of them all. Let's say John, our one and only employee in the IT department, decides to take a new job somewhere else. What happens then? We do the logical thing. We delete his record and poof! We just accidentally wiped the entire existence of the IT department off the map. We no longer have any record that it even exists or where it was located. This kind of catastrophic data loss is called a deletion anomaly. Okay, so to fix these messes, these anomalies, we need to look deeper. We have to stop just looking at the data itself and start understanding the hidden rules that are secretly running the show. And these rules have a name. They're called functional dependencies. A functional dependency is actually a super simple idea. It's just a rule that says if you know the value of X, you can be 100% certain of the value of Y. No exceptions. We write it with that little arrow. X determines Y. For example, in this simple student table, a student ID uniquely determines their name, right? It also uniquely determines their age. You just can't have two different names for the same student ID. That's a functional dependency in action. And this, right here, gets to the absolute heart of our problem. Our original messy table was trying to enforce a bunch of these rules all at once. An employee ID determines a name, sure, and a department name determines its location. The problem wasn't the rules were fine. The problem was that the table's structure forced them all into conflict. So now that we've diagnosed the disease, we can finally talk about the cure. And it's an incredibly powerful process called database normalization. Honestly, normalization is just a fancy term for intelligently breaking up those big, problematic tables into smaller, more logical ones. The whole idea is that each new table is designed to handle just one thing and one thing only, respecting its own rules. So let's actually see this happen. We're going to take our broken, anomaly-filled table and restructure it into something clean, efficient, and most importantly, reliable. And the solution is so elegant, it's beautiful. Instead of one giant table trying to do everything at once, we just split it into two logical parts. One table just for employee information, and another one just for departments. Now look at this. In the department table, each department's location is stored exactly once. So if HR moves, we update one single entry. Done. We can add our new innovation department, no problem, even without any employees. And if John from IT leaves, we delete his record from the employee table, but the IT department's info stays perfectly safe in its own table. All three anomalies solved, just like that. All right, so our data is perfectly organized. But now, how do we find any specific piece of information? How can we guarantee that we can pinpoint one specific employee or one department out of millions? Well, for that, we use keys.
The most important one is called a candidate key. Just think of it as the perfect unique ID for any row in a table. In our new employee table, the employee ID is the candidate key. For any given ID, there is only one possible employee. It's the ultimate address for that piece of data.
So, how do designers actually find these keys in massive real-world tables with dozens of columns? They use a formal process called finding the attribute closure. It sounds complicated, but it's really just a method for testing which column or combination of columns has the power to uniquely determine all the other information in that row. And finally, in those huge real-world databases, that list of hidden rules, those functional dependencies, can get incredibly long and complicated. To manage all that complexity, designers have one last trick up their sleeve. It's called finding the canonical cover. Basically, the goal is to take a huge, messy list of data rules and mathematically boil it down to the smallest, simplest set of rules that still does the exact same job. It's like taking a 1,000-page instruction manual and creating a one-page cheat sheet that works just as well. It makes the whole database faster and so much easier to maintain. So,